All right, everyone. Welcome back to the channel. Um, let's start. May-June 2025, variance 41, paper 4 of A-level chemistry or A2 chemistry. So we need to attempt all the questions. Let's see what we have in the question number 1. Oh, that's an empty page. Oh, that's question number 1. Both calcium carbonate, my bad, that's not good color. Calcium carbonate and barium carbonate decomposes when heated to form metal oxide and gas. So when calcium carbonate is decomposed on heating, it will turn to calcium oxide and carbon dioxide. And when barium carbonate is decomposed on heating, it will turn to barium oxide and carbon dioxide. And that's what we have done in the class also. So calcium oxide and barium oxide both are metal oxide, whereas carbon dioxide is a gas. All right. I hope it makes sense to you. So examiner is looking for an equation in which we need to decompose calcium carbonate through heating. So the equation is quite easy. Calcium carbonate, when decomposed on heating, it will turn to calcium oxide and carbon dioxide. Since examiner is not looking for the state symbols, so I'm not going to write them, okay? But you should remember such things. This is solid, this is also solid, this is a gas at room temperature and pressure. Now state which calcium carbonate or barium carbonate decomposes at lower temperature. So lower the temperature, easier the decomposition. And decomposition is easier means that metal ion has a high charge density. And we know that calcium ion has a higher charge density than barium ion, which means calcium carbonate decomposes at a lower temperature. So the compound that decomposes at lower temperature is calcium carbonate. And examiner is looking for the explanation also. So let me tell you one thing, that calcium ion has a smaller ionic radius than barium ions. All right, which means calcium ion has high charge density. If calcium ion has a high charge density, then it means calcium ion is a strong polarizing power. If calcium ion has a high polarizing power, which means it can easily distort it, it can strongly distort it. the electrons of carbonate ions hence decomposition takes place at low temperature. In the next part of the question, calcium oxide reacts with water to form compound A. So let me write the equation first. We have done that in group 2, I believe, in A1. So when calcium oxide is placed in water, it will turn to calcium hydroxide. By the way, calcium hydroxide is also called lime water or slake lime. When barium oxide is placed in water, it will turn to compound B. Obviously, it's going to be converted into barium hydroxide. My bad. Barium oxide. When placed in water, it will turn to barium hydroxide. Okay. So identify A. Obviously, it's going to be calcium hydroxide. All right. Now, the next part of the question is why A is less soluble than B. So why calcium hydroxide is less soluble than barium hydroxide? In other words, you can also say that why the solubility of hydroxides increases down the trend. So this is compound A and this is compound B. So first of all, down the trend, charge density decreases, which is why lattice energy of calcium hydroxide is greater than barium hydroxide. So down the group, ionic radius increases and charge density decreases. All right, which means calcium hydroxide has higher charge density so it has so its lattice energy is more exothermic than barium hydroxide. As a result, its hydration enthalpy is also more exothermic. Hence, standard enthalpy change of solution becomes less exothermic. And that's the end of this first question. Well, it seems this question is related to rate of reaction. Three experiments are carried out to investigate the reaction of nitrogen monoxide, which is also called nitric oxide, with chlorine. The equation for this reaction is given. All right. The rate equation for this reaction is shown. So with respect to NO, it is second order. With respect to chlorine, it is first order. So that's a very, very important rate of reaction equation or rate equation. Under the conditions used in experiment 1 and 2, the value of K is 26.4. The rate of reaction is measured in mole per dm cube second inverse. Determine the unit of K. So that's an easy thing. Rate has a unit of mole per dm cube second inverse. K will remain as it is. Now this NO has a square, which means its unit is going to be mole squared dm minus 6 into the concentration of chlorine has only 1 power 1, which means its unit is mole per dm cube. So unit is going to be mole per dm cube per second, or second inverse is the same thing, equals to K. When the two units are multiplying together, so I'm going to add up the powers. So it's going to be mole cube dm minus 9. So unit is going to be, I believe, mole is inverse 2, dm6, and second inverse. All right. I hope it makes sense to you, because they will cancel out with each other. So we are going to get this one. In experiment 1, the initial concentration of NO and chlorine are equal. That's very, very important. Very, very important. The initial rate of reaction in experiment 1 is this, mole per dm cube second inverse. Calculate the initial concentration of NO. Show your working. So that's an easy thing. Let me write the rate equation again. Rate equals to K, concentration of NO, power square, and concentration of chlorine. The rate of reaction for experiment 1 is already given, which is 2.57 into 10 to the power minus 6. The value of K is already given, which is 26.4. So I'm going to use that value. We need to find the concentration of NO, because that's the question, and the concentration of chlorine. Okay. So the initial concentration of NO and chlorine are equal. And that means I'm going to use its x square and then x. So it's going to be x cube. All right. So 2.57 into 10 to the power minus 6 equals to 26.4. We need to find the concentration of NO. Since we don't know the value, so let's suppose it's x, and since it has a square, so obviously it's going to be x square. And obviously the concentration of chlorine is also same, so I'm going to take it x. It's going to be x cube, because power hydrogen. So the value of x from here is going to be 4.60 into 10 to the power minus 3 mole per dm. That's the answer. In experiment 2, the initial concentration of NO and chlorine are both 10 times greater than the initial concentration used in experiment 1. Calculate the initial rate of reaction in experiment 2. 10 times greater. 10 times greater. Okay. So that's an easy thing. Let me write the rate equation again. Rate equals to K, concentration of NO power square, and concentration of chlorine. We know the value of K. We know the concentration of NO and chlorine. So we can find the value of rate. So the concentration of NO is 4.60 into 10 to the power minus 3. So concentration of NO is 4.60 into 10 to the power minus 3. Multiply by 10 because it is 10 times greater. So it's going to be how much? 0.046 mole per dm cube. Similarly, the concentration of chlorine is also 10 times. And since NO and chlorine have equal concentration in the previous part, so I'm going to use the same value for chlorine also, and I'm going to multiply it by 10. So I'm going to get the same amount, mole per dm cube. I'm going to put these two values in the rate equation. So K is 26.4. The concentration of NO is 0.046 square. And the concentration of chlorine is also 0.046. So rate of reaction from here is going to be 2.56 times 10 to the power minus 3. And the unit of rate is going to be mole per dm cube. And second inverse. And that's the answer, guys. Okay. So its answer is 2.56 into 10 to the power minus 3. And the answer for the concentration of NO is 4.60 into 10 to the power minus 3. Let's move on to the next part of the question. Now, in experiment 3, uses large excess of NO. If it uses large excess of NO, that means the concentration of NO needs to be constant because we cannot determine the concentration if any substance exists in excess amount. All right. The initial concentration of chlorine is 2 into 10 to the power minus 4 mole per dm cube. The graph of concentration of chlorine against time shows that the reaction has a constant half-life. If reaction has a constant half-life, guys, remember, it must be the first order reaction. All right. So explain this observation. With respect to chlorine, it is first order reaction because the concentration of NO is constant, so it has no effect on the rate of reaction. Okay. Under the condition used in experiment 3, the value of the rate constant is 105.6. Show that half-life of chlorine is 6.56 into 10 to the power minus 3 second under these conditions. So since chlorine has a first order reaction, and for first order reaction, the half-life formula is going to be 0.693 over K. K is basically the rate constant. And the rate constant is already given in the question, which is 105.6. So I'm going to put this value in the formula and I'll get the answer. 0.693 divided by 105.6. So it's going to be how much? 6.5 into 10 to the power minus 3 seconds. Okay. 0.693 divided by 105.6. Yeah, 6.56 into 10 to the power. Yeah, 6.56 into 10 to the power minus 3 seconds. Okay. Calculate the time taken in seconds for the concentration of chlorine to fall to 1.25 into 10 to the power minus 5 mole per dm cube in experiment 3. So technically what's going on here? Initial concentration is basically 2.0 into 10 to the power minus 4 molar. Molar or mole per dm cube is the same thing. Okay. And that was the initial concentration given. Where is that concentration? Let me check this one. This one. This is given. Okay, that's value is important, guys. You need to remember this value. That was the initial concentration of chlorine in experiment 3. Okay, so it decreases to 1 into 10 to the power minus 4. Hold on. The thing is, the initial concentration is 2.0 exponent minus 4 divided by 5. 4 into 10 to the power minus 5. Okay. Oh my goodness. I've got this. Initially, the concentration is 2 into 10 to the power minus 4. So it is converted into 2 into 10 to the power minus 4 mole per dm cube. That's the first conversion. Now in the second conversion, 1 into 10 to the power minus 4 mole per dm cube is converting into 5 into 10 to the power minus 5 molar. Now in the third conversion, 5 into 10 to the power minus 5 molar is converting into 2.5 into 10 to the power minus 5 molar. And when 2.5 into 10 to the power minus 5 molar is converting into 1.25 into 10 to the power minus 5 molar. All right. So concentration decreases 4 times, right? When you halve this, you will get this one. When you halve this, you will get this one. When you halve this, you will get this one. When you halve this, you will get this one. So from initial concentration 2 into 10 to the power minus 4 to this concentration technically decreases 4 times. All right. So if concentration decreases 4 times, so in order to determine the half-life, I'm going to multiply the value of this half-life into 4. So for half-life, value is 6.56 into 10 to the power minus 3. I'm going to multiply this value by 4 because concentration decreases 4 times. So we need to multiply the value of half-life by 4. So it's going to be how much? Hold on, 6.56 exponent minus 3 into 4. So it's going to be 0.02624. And that's the answer, guys. I hope it makes sense to you. Now, in the next part of the question, sulfur dioxide reacts very slowly with oxygen in the atmosphere, forming sulfur dioxide. Okay. This reaction is much faster in the presence of NO. Explain the role of NO in this process. Include chemical equations in your answer. By the way, NO is acting as a homogeneous catalyst. And homogeneous catalyst means reactants and catalysts exist in same physical state. Obviously, NO will recover at the end of the reaction because that's the characteristic feature of all the catalysts, okay? So let me write the equations to support my answer. Nitrogen monoxide exists in the atmosphere. Now that atmosphere also contains oxygen. They will react together, converted into nitrogen dioxide gas. Now this nitrogen dioxide gas is acting as an oxidizing agent, and it oxidizes sulfur dioxide in the atmosphere into sulfur trioxide and reduces itself. So technically reaction starts from NO. At the end, we have got NO gas again, which means acting as a catalyst. Since reactants and catalysts exist in same physical state, which is why it is an example of homogeneous catalyst. Excuse me. Thank you very much. That's the end of second question. Let's move on to the third one. This question is related to ionic equilibria. Chromium 3 hydroxide is only slightly soluble in water. The value of the solubility product of chromium hydroxide is 1 into 10 to the power minus 33 at 298 Kelvin. Complete the expression for Ksp of chromium hydroxide includes the units. Let me write down first the equation. So that's chromium 3 hydroxide. Ionizes into its chromium 3 ions. And hydroxide ions. So let me write the Ksp expression now. Ksp is always the concentration of chromium ion and concentration of hydroxide ions. And since hydroxide has 3 moles in the equation, it has to be in the power now. Unit is going to be easy. The unit of chromium 3 ions is mole per dm cube. The unit of hydroxide ion is mole per dm cube. Since it has power q, so its unit is going to be mole q dm minus 9. We need to add the powers since the units are multiplying together. So it's going to be mole 4 dm minus 12. So unit is going to be mole 4 dm minus 12. All right. Calculate the solubility in gram per dm cube of chromium hydroxide in pure water at 298 Kelvin. Show your working. My goodness. We have 3 marks. And examiner has given us what? Ksp ki value. I'm going to use this value in order to get the solubility of chromium hydroxide in gram per dm cube. And again, that's an easy thing. It's all about calculation. So in the first part, Ksp equals to concentration of chromium ions and concentration of hydroxide ions, power Q. The value of Ksp is given, which is 1.0 into 10 to the power minus 33. Okay. Let's suppose chromium. Well, according to the equation, chromium ion has 1 mole, whereas hydroxide ion has 3 moles. Since we don't know the concentration of chromium ion, so let's suppose I'm going to use X here and I'm going to use 3X here. So X here and 3X here. Okay. Let me put this X and 3X in the relevant expression. So this is X for chromium ions and this is 3X for hydroxide ions. Since hydroxide has 3 moles, so it has to be in the power. So this is going to be 27x4 equals to 1.0 into 10 to the power minus 33. Obviously, I'm going to take the value of X. So the value of X from here is technically 2.47 into 10 to the power minus 9 mole per dm cube. Okay. You know, chromium 3 ions and chromium hydroxide has 1:1 ratio according to the equation. So if you have got the concentration of chromium 3 ions is 2.47 into 10 to the power minus 9, it's going to be the same concentration of chromium hydroxide also. Okay. Two 2.47 into 10 to the power minus 9 mole per dm cube. Okay. The MR of chromium 3 hydroxide I believe is 103. Chromium is 52 plus 17 times 3 is 103. So the final answer in gram per dm cube equals to mole per dm cube into MR. Mole per dm cube is 2.47 times 10 to the power minus 9 into MR is 103. So the value is going to be 2.54 into 10 to the power minus 7 gram. Let me check it again. Into 2.47 exponent minus 9. 2.54 into 10 to the power minus 7. Yeah, that's the answer. Minus 7. And that's my answer, okay? So chromium 3 hydroxide is less soluble in 0.1 mole per dm cube NaOH than it is in pure water. Explain this observation. By the way, pure water ionizes very slowly. So I'll get negligible amount of hydroxide ions, okay? Slowly ionizes, negligible amount of hydroxide ions. Negligible amount of hydroxide ions. But sodium hydroxide ionizes fully because it is a strong alkali. So technically, it increases the concentration of hydroxide ion in a saturated solution of chromium hydroxide. So when you add NaOH, it increases the concentration of hydroxide ions. So this favors the equilibrium towards left-hand side, and as a result, precipitation increases, whereas solubility decreases. And that's what the examiner gives us the information. So NaOH increases the concentration of hydroxide ion in a saturated solution. So equilibrium favors towards left hand side due to common ion effect. All right, let's start part B. The value of the acid dissociation constant Ka of butanoic acid is 1.5 into 10 to the power minus 5. So the value of Ka is given. Calculate the pH of 0.1 mole per dm cube butanoic acid. So concentration is given, Ka ki value is given, which means I can find the value of pH by using an expression which we have done in the class. pH equals to minus log under root Ka times concentration of acid. We can use this expression for all the weak acids, okay? We know the value of Ka, we know the value of concentration of butanoic acid. Just plug in the values, you will get the pH value. And that's what the examiner is looking for. The value of Ka is 1.51 into 10 to the power minus 5 into concentration of acid is 0.1. So the value of pH is going to be, I think, 2.91. Let me check it again. 1.51 exponent minus 5 into 0.1. Answer under root minus log answer 2.91. That's the answer. Okay. Now in the next part of the question, examiner is looking for the pH when the concentration of NaOH is 0.1 mole per dm cube at 298 Kelvin. That's easy. Let me show you the working. NaOH is a strong alkali. It ionizes fully into its sodium ions and hydroxide ions. According to the equation, 1:1 का ratio है. So अगर हमारे पास concentration है 0.1 mole per dm cube, which is also called molar. So the concentration of hydroxide ion is also same. That is 0.100 mole per dm cube. Since we know the concentration of OH ions, we can find the value of POH, which is minus log concentration of hydroxide ions. So the POH value is going to be minus log 0.1 is going to be 1. So the value of POH is 1. We need to find the value of pH. So I'm going to use the expression pH plus POH equals to 14. So pH is going to be 13. And that's the answer. Okay. Instead of using all these steps, you can use Kw equals to concentration of hydrogen ion and concentration of hydroxide ion expression. You know the value of Kw. You know the concentration of hydroxide ions. You will get the concentration of H plus ions. If you take the negative log of that hydrogen ion concentration, you will get the value of pH, and that's going to be the exact value. That is 13. So that's alternate method to get the pH value, which we have done in the class also. Let's move on to the next page. 5 cm cube of 0.1 mole per dm cube NaOH. So the concentration and volume of NaOH is given. By using these two values, I can find the moles. So that's going to the first step, obviously. And again, the concentration and volume of acid is also given. I'm going to get the moles also. Calculate the pH of the resulting solution. Show your working. My goodness. Oh, that's a huge amount of, for 2 marks, that's a lot of working. Okay, no problem at all. Can do that. Let me find the moles of NaOH first. 5 multiplied by 0.1 divided by 1000. So I'll get how much moles? 5 into 10 to the power minus 4. 5 into 10 to the power minus 4. Yes, that's correct. Let me get the moles of acid. I know the volume. I know the concentration. So 10 into 0.1 divided by 1000. 1 into 10 to the power minus 3 moles. Okay. Now this butanoic acid is a weak acid, and according to my lecture, all weak acids are generally represented by Ha. So in order to make an equation, I'm going to use Ha instead of this formula, okay? So Ha, that is butanoic acid, is reacting with NaOH, converting into salt and water. That's your salt and water. So we know the initial moles of both acid and alkali. Acid has an initial moles of 1 into 10 to the power minus 3. Alkali has an initial moles of 5 into 10 to the power minus 4. Initially, products are 0. So when we mix these two substances, they will react together. And obviously, when they will react together, some amount of moles should be left, right? Obviously, NaOH is the limiting reactant because it has less number of moles. So if it is a limiting reactant, so 5 into 10 to the power minus 4 moles will react. Ultimately, 5 into 10 to the power minus 4 moles of products are formed. So 5 into 10 to the power minus 4 moles of salt and 5 into 10 to the power minus 4 moles of water are also produced. हम बफर के अंदर water use नहीं करते. I'm going to ignore the moles of water now. Okay. The initial amount of acid is 1.0 into 10 to the power minus 3. Since it has 1:1 ratio, so if this much amount of NaOH is used or consumed during the reaction, the same amount of acid is also consumed due to 1:1 ratio. So I need to subtract 5 into 10 to the power minus 4 moles from the initial moles of acid. So I'm going to get what? Sorry. 5 into 10 to the power minus 4 moles. Okay. The total volume in the beaker is 15 cm cube, guys. If you remember the concept, we have done this in the class. So total volume of solution into the beaker is 15 cm cube. That means the acid has a 15 cm cube volume. That means salt has a 15 cm cube volume. So if I'll put this volume into the Henderson equation, because of the ratio, they will cancel out with each other. So these moles are technically the concentration. Okay. So I'm going to use Henderson equation. pH equals to pKa minus log concentration of acid, which is 5 into 10 to the power minus 4 divided by 15 because of total volume, over concentration of salt, which is 5 into 10 to the power minus 4 divided by 15. Okay. pKa, My goodness, there's a lot of calculation. pKa equals to minus log Ka. All right. Minus log Ka. The value of Ka is already given in the previous part of the question, which was 1.51 into 10 to the power minus 5. 1.51 into 10 to the power minus 5. So the value of pKa is going to be how much? I think 4.82. Let me plug in this value. 4.82 minus log. Obviously, because of ratio, they will cancel out with each other. So it's going to be log 5 into 10 to the power minus 4 divided by 5 into 10 to the power minus 4. When you divide these two values, you will get 1, and log 1 is basically 0. So the pH is basically 4.82. It will remain same. And by the way, that's also called half neutralization point, where the concentration of acid and the concentration of salt are equal. Because at half neutralization point, the value of the value of pKa is always the value of pH. Okay, if you remember, we have done that in the class. My goodness. Next part of the calculation, 80 cm cube of the aqueous solution. That means the amount of water is 80 cm cube containing 0.704 gram of butanic acid is shaken with 100 cm cube of benzene. By the way, aqueous solution is water, which is polar. Benzene is a hydrocarbon, it is a non-polar. Obviously, they will not gonna mix together, and obviously you will get the immiscible solution. If you get the immiscible solution, I can extract the amount of benzoic acid. All right. So there is examiner is saying 0.556 gram of butanic acid is extracted in 100 cm cube of benzene and equilibrium. So calculate the partition coefficient of KPC between hexane and water. Show your working. Okay. Let me take out the information. Let me take out the information first. First of all, the mass of benzoic acid. So the mass of benzoic acid zero 0.704 gram. Volume of water, and that's going to be your aqueous layer, is 80 cm cube. Then volume of benzene, that's going to be the organic layer, is 100 cm cube. According to the information, 0.556 gram of benzoic acid is extracted in 100 cm cube of benzene at equilibrium. So obviously, I'll get the concentration. So the concentration of benzoic acid in benzene is going to be 0.556 divided by 100. So it's going to be how much? 5.556. My bad. hold on, 0.556 divided by 100, 5.56 into 10 to the power minus 3 gram per cm cube. Okay. So we had this much amount of mass from which we have extracted 0.556 gram in benzene. So if I subtract these two values, I'll get the amount of benzoic acid which was dissolved in water. So let me take out that value. So mass of benzoic acid in water. The initial amount is 0.704. The amount extracted in benzene is 0.556. So the amount of benzoic acid dissolved in water is going to be 0.704 minus 0.556, 0.148 gram. Let me take out the concentration. Of benzoic acid in water. So it's 0.148 divided by 80. So you will get 1.85 into 10 to the power minus 3. 1.85 into 10 to the power minus 3 gram per cm cube. All right. So I've got the concentration of benzoic acid both in organic and aqueous layer. Let me find out the value of KPC, which was the examiner requirement. Now we need to take this value in the numerator and this value in the denominator, because benzene and examiner was asking for partition coefficient between hexane and water. So 5.56 into 10 to the power minus 3 divided by 1.85 into 10 to the power minus 3. So it's going to be how much? 5.56 exponent minus 3 divided by answer. So it's going to be exactly 3.00. So the value of KPC here is going to be 3.00. All right. So that's the end of this question. So let's start another question. That is question number 4. Okay. Table 4.1 gives enthalpy changes of hydration for 3 ions: fluoride, potassium ion, and calcium ion. Now, calcium ion has the higher and hydration enthalpy value, whereas potassium ion has a lower hydration enthalpy value. So, for first part of the question is enthalpy change of hydration. Enthalpy change occur when 1 mole of gaseous cation and anion is dissolved in large amount of water. To give an infinite dilute solution. Explain the relative magnitudes of the enthalpy changes of hydration of potassium ion and calcium ion. So, Potassium and calcium both are found in the same period of the periodic table, but they are found in different groups, all right? So potassium is found in group 1 of the periodic table, whereas calcium is found in group 2. As the magnitude of charge of calcium ion is higher, which means it has higher charge density. So, calcium ion has a higher charge density than potassium ion. So calcium ion forms a strong electrostatic bond between between calcium ion and water. So its hydration enthalpy is more exothermic. Okay. Also, you can even say that potassium ion has a larger ionic radii. Now the next is define lattice energy. Enthalpy change occur when 1 mole of ionic solid is formed from gaseous cation and anion. Okay. The lattice energy of calcium fluoride is this. Enthalpy change of solution, we need to find out. Okay. So hydration of calcium ion is given. Hydration of fluoride ion is given. So hydration of calcium fluoride is given. Lattice energy is given. I can find the value of solution. So I'm going to use this expression, which we have discussed in the class. Standard enthalpy change of solution equals to minus lattice energy plus hydration enthalpy. Minus lattice energy is minus 2602. Hydration of calcium ion is given, which is, I believe, 1650. Yeah. And hydration of fluoride ion is given, which is minus 506. We need to multiply by 2 this value because formula contain 2 fluoride ions. Okay. So the value of standard enthalpy change of solution from here is minus 60 kilojoules per mole. So that's the answer, minus 60 kilojoules per mole. Okay. Let's move on to the next page. The formation of calcium fluoride at 298 Kelvin is shown. Delta H value is given, delta G value is given. Examiner is looking for the entropy change in joules, Kelvin inverse, mole inverse. That's an easy thing. Let's use Gibbs free energy change relationship, which is always equals to standard enthalpy change of reaction minus T delta S naught. Okay. The enthalpy change of reaction is minus 1214 minus T is 298 Kelvin. That is at room temperature and pressure. And we need to find out the value of delta S naught. And the value of delta G is minus 1162. So the value of delta S naught is going to be minus 174.5 joules, mole inverse, and then Kelvin inverse. Okay. Or you can write joule, Kelvin inverse, and mole inverse. So minus 174.5 is going to be the right answer. So that's the end of question number 4. That was the easiest question, I must say. Let's move on to the question number 5. Oh, that's my favorite. Transition element. Complete the electronic configuration of copper ion and copper 2 ions. When we talk about copper 1 ions, which means one electron is lost from the 4s orbital, so electronic configuration is going to be argon and then 3d10. When we say copper 2 ions, which means 2 electrons are lost from the valence shell, 1 electron is lost from the 4s orbital, the second electron is lost from the 3d orbital, so obviously 3d contain 9 electrons now. Explain why transition elements have variable oxidation state. Well, it has 2 reasons. The first one is close proximity of energy of both 4s and 3d orbital or subshell. Also, electrons are available both in 3d and 4s. Okay, next is aqueous copper 2 sulfate contained this ion. When we had few drops of aqueous ammonia are added to copper 2 sulfate, describe any observation made. Well, let me show you the equation. That's pale blue solution of aqueous copper 2 sulfate. When treated with few drops of aqueous ammonia, my goodness, when we talk about few drops, I'm going to write 2NH3 here. Acid-base reaction takes place, also called precipitation reaction. And obviously pale blue precipitates are formed. Write an equation for the reaction taking place. So I need to write this equation here. CuH2O taken 6, 2 plus 2NH3. That's an acid-base reaction, also called precipitation reaction. you will get copper, H2O taken 4, OH taken 2, plus 2 ammonium ions. When an excess aqueous ammonia is added to this, describe any further observation made. Dark blue solution is formed. And the equation can be written like this. By the way, we have done this equation in class. So it could be written like this. This is called ligand substitution reaction. And examiner is looking for the name of the type of the reaction taking place, ligand substitution reaction, which is also called ligand exchange reaction. Okay. So examiner was looking for the reaction between excess aqueous ammonia and copper sulfate aqueous. So technically examiner is looking for these two reagents. Okay. Let's move on to the next page for the question. Okay. Copper metal can be oxidized by acidified KMnO4. Copper is basically a reducing agent. Manganate ions is basically an oxidizing agent. So going to be the redox reaction. The half equation for copper ions and manganate 7 ions is already given. And both the electrode potentials have positive SCP values, right? MnO4 negative, Mn2 plus electrode is constructed using 0.002 mole per dm cube. So the concentration of manganate ions is not under standard condition anymore, right? And the concentration of manganese 2 ions is 1 mole per dm cube. Concentration of hydrogen ion is 1 mole per dm cube. The temperature will remain 298 Kelvin. Use the Nernst equation to show that the E value of this manganate ions electrode is plus 1.49 volt. So we have done Nernst equation in the class. E equals to E naught minus 0.0591 upon N log concentration of product over reactant. That was the expression I have given you in the class. Okay. The value of E naught for manganate half cell is plus 1.52 volt minus 0.0591 upon N. Half cell equation shows that it has 5 electrons, so value of N should be 5 log concentration of product over concentration of reactant. See, this is the product and it has a concentration of 1 mole per dm cube. This is the reactant, which is 1 mole per dm cube. This 1 mole per dm cube for hydrogen ion, and the concentration of manganate ions is now 0.0020. So the value of E for manganate half cell is going to be plus 1.49 volt. Okay, I hope it makes sense to you. Oh. An electrochemical cell is constructed using a standard copper half cell and manganate electrodes described in D1. Calculate the value of E cell. This is electrode cell. This is called cell potential standards. This is called cell potential under non-standard condition, okay? So in order to get the value of each cell, is going to be E naught right minus E naught left. E naught right is 1.49 because it has a more positive SEP value. So I need to put it E naught right. E naught left is copper. Copper is plus 0.34 volt. So the value of E cell is going to be plus 1.15 volt. Okay. Write an equation for the reaction taking place in the electrochemical cell described in D2. Obviously, this half cell has a more positive SEPI value. So I will write it down as it is in the reduction form. And obviously, we have different number of moles. So to balance the moles, I need to multiply 5 by this equation and 2 by this equation. On the basis of that, we can cancel out the number of electrons, and then I can write the whole equation. I hope it makes sense to you. I repeat again, we have different number of moles in both the equations, so we need to balance these moles. And for that, I'm going to multiply this equation by 5, and I'm going to multiply this equation by 2. As soon as we multiply the number of as soon as the number of electrons are balanced, they will cancel out with each other, and we can write the final equation. So I'm going to write 2 MnO4 negative plus 16 hydrogen ion plus 5 Cu2 plus on the reactant side. 2 MnO4 negative plus 16 hydrogen ions plus 5 Cu2 plus, 5 Cu, because we need to reverse this equation. Okay. Arrow. Oh my goodness, we need to remember such things. It's going to be 5 Cu2 plus 2 Mn2 plus 8 H2O. So let me tell you one more time. This half cell has a more positive SEP value. So we need to write this half cell as it is in the reduction form. In order to write in the oxidation form, we need to flip this equation. All right, that is the first step. In the second step, we need to balance the number of electrons, and for that, I need to multiply this equation by 5 and this equation by 2, and as a result, we can cancel out the number of electrons, and the final equation is going to be like this after the flipping of iron copper half cell equation. Okay, I hope it makes sense to you. Oh my goodness. Complete the sentences for the electrochemical cell described in D2. The dash electrode is the negative electrode. Obviously, if two half cell is a positive electrode, half cell with a more positive value is a positive electrode, half cell with a less positive value is a negative electrode. So obviously, copper half cell has a lower SCP value, which means it's going to be the negative electrode. And as a result, electrons flow from copper half cell to MnO4 negative to Mn2 plus half cell. Okay. Half cell with a more positive SCP value undergoes reduction. Half cell with a less SCP value undergoes oxidation. Undergoes oxidation means we need to flip this equation. Okay. Remember that. A solution containing this much copper ions is electrolyzed in 5 hours. So technically time is 5 hours. We need to convert it into seconds. So 1 hour is 60 minutes, 5 hours is 300 minutes, 300 minutes into 60 because 1 minute equals to 60 seconds. So it's going to be how much? It's going to be 18,000 seconds. Okay, that's my first step. Second, this much amount of copper metal is formed, which means I can find the moles of copper. 0.764. divided by 63.5. It's going to be 0.01203 moles. An examiner is saying that copper metal is formed at cathode, which means we need to consider this equation, which takes place at cathode, in which copper ions gain electrons and converted into copper metal. According to the equation, ये 2 mole. According to the equation, ये 1 mole. अगर ये 0.01203 moles हैं, so moles of electrons is going to be 0.02406. All right. Examiner is looking for the electric current in A ampere used with 3 significant figures. Okay. We know the moles of electrons. We know charge. We need to find out the charge by using the Faraday constant. So moles of electrons into Faraday constant. Moles of electrons is 0.02406 into Faraday constant is 96500. So the value of charge is basically 2322.07. Now in the last part of the question, Q equals to I times T. We know the value of Q, which is 2322.07 equals to, we need to find out the current, and the time is 18,000 seconds. So the current is going to be actually, oh my goodness, 2, 3, hold on, into 96500, 2322 point something, divided by 18,000, 0.1290. 0.1290 ampere. Okay, and that was the current used. That's the end of this question, guys. All right, let's move on to the next question. That is question number 6. Iron forms complex ions with monodentate ligands. Monodentate means donate only one lone pair to the transition metal ion. Okay. Now examiner is saying complex ion A contain 1 Fe3 plus and 6 cyanide ions. Okay, so the complex ion formula is going to be FeCN taken 6. And since we need the oxidation state of iron is 3 plus, which is why we need to put 3 negative sign here. Now in the next part, complex ion B contain 1 Fe2 plus ions and 6 cyanide ions. Okay, so technically the formula of this complex ion is going to be FeCN taken 6. And since we need oxidation state of iron is 2 plus, which is why I need to put 4 negative charge here. Okay, state the formula of the two complex ions. Okay, that's easy. Include overall charge of each complex. That's what I've told you. Fe, Cn taken 6, 3 negative, then Fe, Cn6, 4 negative. Okay. Explain why a solution containing complex ion A and a solution containing complex ion B are different colors. Different colors क्यों हैं दोनों के? So first of all, both of them have different oxidation state. Both Fe2 plus and Fe3 plus have different oxidation states and electrons in d orbital, due to which they will undergoes different splitting pattern, and so they have different energy. Hence, they will show different color. Okay. In complex ion A, the carbon atom of each cyanide ligand bonds to the iron 3 ions. State the type of bonding involved. Whenever complex ion is formed, dative bond is formed. Dative bond is also called coordinate covalent bond. Okay. Uh, I hope it makes sense to you. That's related to the splitting theory, which we have done in the class. Okay. Um, let me explain this more so that you will get the idea. Okay. When we talk about Fe2 plus, it contain 6 electron in the d subshell. So let me arrange d6 system in an octahedral complex, because 6 ligands are attached to the transition metal line, which means it has an octahedral geometry. Okay. Okay. Now we have 6 electrons. 1, 2, 3, 4, 5, 6. Distribute these electrons among T2G and EG. So it's basically 1, 2, 3, 4, 5, and 6. So there is a different arrangement of electrons. Okay. So that's what I have written. And electrons in the d orbital, different electrons in the d orbital. Okay. Let me show you iron 3 ions. Since it has 5 electrons in the d orbital, so it shows d5 system. Now we have 5 electrons. 1, 2, 3, 4, and this one is 5. 1, 2, 3, 4, and this one is 5. Now, see, we have different arrangement of electrons in the d orbital, which is why they will have different splitting pattern, which is why they have different absorption region, which is why they will show different complementary colors. All right. So there is a different dd transition in both the system. Okay. तो मैंने उसको काफी समराइज्ड करके यहाँ पर लिख दिया है. आप चाहें तो इसमें काफी चीजें ऐड कर सकते हैं. इसमें एक पॉइंट आप ऐड कर सकते हैं, डिफरेंट ऑक्सीडेशन स्टेट, चूंकि मैंने अपने आंसर में लिखा भी है. ठीक है. दूसरी बात, आपको पता है कि साइनाइड इज द स्ट्रॉन्गेस्ट ligand, which is why low spin complexes are formed, which is why all the electrons fills only in T2G. So different arrangement of electrons in d orbital. Then we have different dd electronic transition. Then we have different energy absorption region. And different complementary color. So that's an alternate explanation for that particular part. मैंने इसी explanation को थोड़ा सा professionally इस तरह से handle करके दिया आपको. Okay, I hope it makes sense to you. आपको समझ में आ रहा हो कि क्या हुआ है. ठीक है. Let's move on to the next page, guys. Complex ions have different geometries. Okay. Complex ion A is octahedral. Silver ions forms a linear complex with ammonia. That's what we have done. Complex ion A has a formula of FeCN taken 6 3 minus. For this complex, it must be AgNH3 taken 2 positive. Nickel atoms forms tetrahedral complex with carbon monoxide molecule. That's tetracarbonyl nickel 2 ion and has a structure like this. Okay. And the carbon atom in the monodentate carbon monoxide bond to the nickel. Okay. Now the next is palladium ions forms square planar complex with chloride ions. All right. So this is palladium. This is Cl4, and this is 2 minus. So complex ion shows the geometry of each of the 4 ions. Use 3-dimensional bonds where necessary. Label 1 bond angle to each complex. So 3-dimensional को हमने देखना है. ठीक है, we have done that in class, and we need to mention 1 bond angle also. Okay. So let me show you. This is octahedral geometry. Oops. Okay. How many cyanide ions? 6. So we need to mention carbon here, 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 and here. Okay. And we need to mention one geometric angle, that's basically 90-degree angle. Okay. Now this is going to be the diamine silver 1 ion bonded with the nitrogen atom, because lone pair of nitrogen is used in order to make the dative bond. Okay. An angle obviously is going to be 180-degree. Nickel with carbon monoxide, it's going to be tetrahedral, obviously. Examiner is looking for the tetrahedral geometry. It's C, 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 and this one is C. Okay. And again, the geometry is 109.5 degree. Palladium has a square planar geometry. That's easy. So this is going to be the square planar geometry, guys. And chloride. This is Cl, this is Cl, this is Cl, and this is Cl. Okay. And obviously the angle is 90-degree among these. So that's the end of question number, I believe, 6. Oh my goodness, there are a lot of questions. Let's move on to the question number 7. Oh, the hydrocarbon is known to be either compound D or E. Give the systematic name of E. So this is going to be the first carbon. E. Oh, that's your E. This is going to be the first carbon, second carbon, third, fourth, fifth, and this one is sixth. Okay. So one ethyl is attached on the first carbon, second ethyl is attached on the third carbon. So its systematic name is 1,3 dash di ethyl benzene. Okay. My goodness, my favorite part of the analytical thing. Proton NMR spectra D and E are compared. They are very similar. The proton NMR spectrum of D is shown in this. Since this shows the TMS peak, this is the first environment, second, and third. Since we have 3 chemical environments, which means, my goodness, that's strange. Okay, let me check. Let me read part 1. Suggest the suitable solvent for obtaining the spectrum. Oh, solvent could be CdCl3, or you can even use CCl4. Okay. Next, the proton NMR spectrum of E is obtained twice, once before and once after shaking with D2O. Describe any differences between these two spectra. Explain your answer. Since E does not have any active functional group, which is why there is no substitution with the D2O, and therefore there will be no change in both the spectra. तो हम यहाँ लिखेंगे no change in both the spectra because D2O can only react CWH, OH, and NH2, which are absent. In E. Okay. Oh my goodness. Complete table 7.1 for proton NMR spectrum of D. Okay, D पे चलते हैं. Let's start with the D thing. Okay. So both of them have same chemical environment. Okay. Let me show you N+1 rule here. This is N+1 rule. Two hydrogen atoms present in the neighbor carbon atom, so it's going to be triplet. Okay, this is going to be the triplet also. So CH3 gives you triplet. So technically both these 6 hydrogen atoms have same chemical environment, and 6 hydrogen have same chemical environment and shows triplet, right? So 6 hydrogen shows triplet peak. So number of hydrogen atom responsible for the peak, 6 hydrogen atom, because both CH3 have same chemical environment. Group responsible for the peak, CH3, and splitting pattern, triplet. Okay, let's talk about this one. If we apply N+1 rule here, now this CH2 contains 3 hydrogen atoms in its neighbor carbon, so it's going to be 4, which means it's quadrate. So this CH2 also represents quadrate, and both CH2s have same chemical environments because they are attached with the same carbon atom with the same distance. So 4 carbon atoms have same chemical 4 hydrogen atoms have same chemical environment, and they will give quadrate. Group responsible CH2, and that's quadrate. Okay. Last but not the least, this benzene ring gives you singlet at a chemical shift of 7.9 to 6.9 to 7.4 delta. Okay. So look, this is triplet peak, this is quadrate peak, and this is singlet peak. All peaks are satisfied. Triplet peak has the lowest value of chemical shift because it is very far away from this functional group. CH2 is closer to the functional group, so its quadrate peak has a little higher value of chemical shift. And benzene obviously has a highest value of chemical shift because of ring current and all that, if you have done in the class. So 7.1 has 4 hydrogen atoms again. 4 hydrogen atoms of the benzene ring, okay? Because 2 groups are attached with the benzene ring, which means benzene has 4 hydrogen atoms. 1, 2, 3, and this one is 4. I hope it makes sense to you. Compound D and E can be distinguished by carbon-13 NMR spectroscopy. State the number of peaks in each spectrum. My goodness. First of all, let me draw structure D. So this is CH2, this is CH3, this is CH2, this is CH3. See, both these carbon atoms have same chemical environment. 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 All right. And these two carbons also have the same chemical environment. So technically we have 5 peaks in D. Let me draw E. Let me draw E. E is 1 and 3. Okay. E is 1 and 3. So this is CH2 and then CH3, and this is CH2 and then CH3. Okay. This is the first carbon atom. This is the second environment. This one is third. And these two carbons are attached to the same group, this one, which means both of them have same environment, fourth. Okay. Also, this carbon has a first chemical environment. This has the same chemical. Oh my goodness, I forgot the second group. Let me show you again. This carbon and this carbon have same chemical environment. This carbon and this carbon have same chemical environment, right? Now this carbon and this carbon have same chemical environment. Okay. Obviously, this carbon and this carbon have same chemical environment because they are attached to the same number of groups and adjacent carbon atom. This carbon is different from all other, and this carbon is also different from all other. All right. आप नोटिस करें ये जो कार्बन एटम है ना, ये 3 कार्बन एटम से अटैच है, जबकि यू बेंजीन की 2 कार्बन एटम से अटैच है, which is why this carbon has different chemical environment. Okay. This is CH, this is CH, but this carbon is attached to this carbon, which has a group attached to it, and this carbon. जबकि यहाँ कोई भी कार्बन के साथ ग्रुप नहीं है. Okay, which is why this carbon has a different chemical environment with this one. It's going to be 6, obviously. Next part of the structure. Compound D can be oxidized to compound F by alkaline KMnO4 followed by dilute acid. So technically, hydrocarbon will turn to CWH. Hydrocarbon will turn to CWH, and for that we need a strong oxidizing agent, that is KMnO4. Excuse me. Write an equation for the reaction using molecular formula for D and F. The products of this reaction are F, water, and carbon dioxide. Use oxygen to represent oxygen atom for oxidizing agent. Okay. Let me count carbon atom 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 carbon atoms. Let me count hydrogen. 3 plus 3, 6, 6 plus 4, 10, 10, 11, 12, 13, 14. 14 hydrogen atoms. Okay. React with the oxygen atom, converting into compound F. 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon atoms. Let me count hydrogen. 1, 2, 3, 4, 5, 6 hydrogen. Let me count oxygen. 2 plus 2, 4 oxygen. Okay. So that's F, carbon dioxide and water. So this is going to be your carbon dioxide. This is going to be your water. Okay. So how many hydrogen atoms here? 40. How many carbon atoms here? 10. We have 8. So we need to put 2 here. So carbon atom balanced. How many hydrogen atoms now? 14. How many hydrogen atoms here? 4. Sorry, 6. 6. 14 करने मैंने, तो 14 उसी वक्त होगा जब यहां पर आप 4 अप्लाई करेंगे. So 4 times 2 कितना हो जाएगा? 8. 8 plus 6, 14. So carbon balanced, hydrogen balanced. Let's talk about oxygen. यहाँ पर 4 है, यहाँ पर भी 4 है, तो 4 plus 4, 8. 8 plus 4, 12. So 12 hydrogen atoms यहाँ, sorry, oxygen atom place करेंगे. I hope it makes sense to you. That's an easy question. F reacts with an excess of thionyl chloride. My goodness. F reacts with thionyl chloride to form compound G. The molecular formula of G is this. Okay. First of all, let me give you a hint here. When we have COOH plus SOCl2 plus SOCl2, ऑब्वियसली यहां से OH चला जाएगा, यहां से भी OH जाएगा, और इन दोनों की जगह पर Cl अटैच होगा. So OH has been removed, and as a result of that, it will turn to acyl chloride. Okay, plus 2 moles of sulfur dioxide plus 2 moles of HCl. 2 moles of HCl. Okay, so that's the compound examiner is looking for. आगे चलते हैं. That's your compound G. By the way, that's your compound G. This is your compound G. Okay, let me copy this compound G. Yeah, there's a compound G. How many carbon atoms here? 1, 2, 3, 4, 5, 6, 7, 8. Carbon balanced. Hydrogen check करें. 1, 2, 3, 4 hydrogen balanced, 2 chlorine balanced, 2 oxygen balanced, G balanced. Okay. Okay. G reacts with ethanol chloride. That's very tricky part of the question, because G is acyl halide, and acyl halide can react with alcohol to give an ester, and that gives the mixture of products, and that mixture contain compound J with a molecular formula and K with a molecular formula. And examiner is looking for the structure of J and K up. Oh my goodness, this has 18 carbon atoms. So let me write down J. Sorry, let me write down G. That's the G. It is reacting with ethane 1 to diol. Okay. Ethane 1 to diol. CH2. This is OH. This is OH. Now from here, I'm going to use chloride. And from here, I'm going to use hydrogen. They will react together to give an ester. with misty fumes of HCl. So structure is going to be like this. CO, this is CO. Now this carbon is attached to this oxygen. Oxygen attached to both carbon atoms. This carbon is attached to oxygen, and this oxygen attached to this. My goodness, that's the scariest structure. I mean, cyclic ring is formed. Let me show you the shape of the graph. I mean, let me show you the color first, and then फिर हम उसको adjust करते हैं. Okay. Hold on a second, please. That's a lot. H from here and Cl from there, you will get HCl. Now I need to attach oxygen. CH2, oxygen, and this is going to be the carbon atom. Okay. बल्कि आप इसको इस तरह से भी कर सकते हैं. This one. So that is going to be the cyclic ring. Okay. And that's the structure examiner is looking for. Let me copy this. Let me draw this. My goodness. Now what happened with that? Still we have 2 chlorine, right? In this formula, we have 2 chlorine atoms. In this formula, we have 2 chlorine atoms. In this formula, we have 2 chlorine atoms. Okay. Let me write down the structure first. इस structure को लिखते हैं सबसे पहले. This is Cl. This is Cl. This is OH, CH2, CH2, OH प्लस इस स्ट्रक्चर को हम एक मिनट और लिख लेते हैं. माय गुडनेस, उसको रिवर्स करके लिखना पड़ेगा यार. चलो करते हैं रिवर्स. एग्जामिनर बहुत ज्यादा हार्ड वर्क करवा रहे हैं हमसे 1 मार्क के लिए, and that's not a good idea at all. This is COCl. Okay. So यहां से H और यहां से Cl. तो बात तो एक ही है. और यहां से H और यहां से Cl. So कुछ ऐसा हो सकता है. तो अगर कुछ ऐसा होगा तो प्रोडक्ट बनेगी. My goodness. Hold on. कोई इशू नहीं है. This is COO. This is CH2. CH2O. CO. This is COCl. And this is COCl. My goodness. That's the structure, I believe. Let me show you the structure first. Yeah. Look the carbon atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So carbon balanced. Talk about hydrogen now. 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hydrogen balanced. We have 2 chlorine atoms balanced. We have 6 oxygen. 1, 2, 3, 4, 5, and this one is 6. So that's the structure, basically. That's the tricky part, I must say. 1 mark के लिए बहुत working करवाई examiner ने. It's a lot of working for 1 mark. I mean, that's not fair at all. That's the end of question number, I believe, 7. That was the lengthy question, by the way. So that was the question number 7. Let's move on to the next question. That is question number 8. Let's see what we have in this question. Seems like related to organic chemistry, specifically methylbenzene. So bromine and methylbenzene react together in dark in the presence of a suitable catalyst like AlCl3 or FeCl3 or AlBr3 or FeBr3 to form HBr and compound L. L is one of the 3 isomers that can form in this reaction. The mechanism for the reaction involves methylbenzene reacting with bromine plus ions. The ion is produced when bromine reacts with the catalyst. Complete the equation by the reaction of bromine with the catalyst. Since we are using bromine, so I'm going to take AlBr3. You can use FeBr3 also. It doesn't make any difference. So it's going to be AlBr4 negative. All right. One of the isomer of L forms is in much smaller amount than the other 2 isomers. Draw the structure of this isomer and explain why it forms in the smallest amount. So since methyl is an orthopara directing group, it activates the benzene ring. So when you react bromine, obviously you will get ortho product and para product. But examiner is saying 3 possible isomers exist. So one is ortho, one is para, and the third one is meta directing group or meta position or meta isomer. So I'm going to write in this like this. CH3, and this is going to be the bromine one. So that's meta position wala group. Why this group has to be in the lowest yield? Because CH3 is in orthopara directing groups. So it directs the electrophile only on second, fourth, and sixth carbon atom. Okay. Complete the mechanism in figure 5.8.1 for the reaction between methylbenzene and bromine plus ion. Include all relevant curly arrows. Okay, that's an easy thing. The pi bond reacts with this electrophile, and as a result, you will get a pi complex. Let me draw the pi complex. So it could either be an ortho product or para product. That's totally up to me. So I'm gonna put bromine on the para position. So this is CH3. It will remain as it is. Bromine is attached to this carbon. This carbon also has 1 hydrogen. Show that hydrogen atom like this. And apart from this carbon, we need to draw the dotted line from here to here and show positive sign. That is going to be your pi complex. Remember, you don't need to extend your dotted line like this. Otherwise, you will lose mark. Okay? That's not the correct thing. Correct thing is like this. This is the dotted line, specifically from this carbon atom to this carbon atom. We don't need to include this one, okay? Now, in order to make the product, we need to neutralize the positive charge of benzene ring. So this bond shifts into the ring so that we can eliminate the positive charge of benzene, and hydrogen in the form of hydrogen ion removes. So product is going to be this. And hydrogen ion. So that's the mechanism, okay? मैंने यहाँ पर fourth carbon atom के साथ bromine attach करके mechanism बनाया है. If you attach bromine with the second carbon atom like this, it's also acceptable, okay? It's also acceptable. So this mechanism is also acceptable in the paper for the examiner. But para has more product, which is why I opt fourth carbon atom. In the next part of the question, chlorobutane and chlorobenzene are added separately to samples of warm aqueous silver nitrate. One of the chloro compounds reacts slowly and the other does not react. Identify the chloro compound that reacts and describe any observation. So by the way, this is going to be the alkyl halide, aliphatic alkyl halide. Aliphatic alkyl halides are more reactive. And this chlorobenzene is basically aromatic alkyl halide. And aromatic alkyl halide, you know, they are chemically inert and unreactive, okay? So identify the chloro compound. So obviously that chloro compound is chlorobutane. And describe any observations. Obviously white precipitate is formed. Write two equations to explain any observation in B part 1. Okay, listen first. This compound has aqueous medium, which means this compound has water. And water can react with alkyl halides. So in the first step, C4H9Cl undergoes reaction with water. That is going to be nucleophilic substitution reaction, and as a result, you will get C4H9OH alcohol plus HCl. Now that HCl is treated with silver nitrate, and as a result, I'll get silver chloride and nitric acid. Okay. Explain the difference in reactivity of chlorobutane and chlorobenzene with warm aqueous silver nitrate. Again, that's an easy thing. In chlorobenzene, being an orthopara directing group, it donates electron into the benzene ring. If it donates electron into the benzene ring, obviously this lone pair is delocalized with a pi bond due to which carbon-chlorine bond becomes stronger. Okay. Hence chemically inert. Whereas in chlorobutane, carbon-chlorine bond is polarized due to dipole moment. Hence, can react easily. Okay. Now the next question is phenylamine and propylamine. Both are amines. One is aliphatic amine and the other one is aromatic amine. Are produced by different reactions. Identify the organic compound that can be converted into phenylamine by reduction reaction. State the reagents and conditions for this reaction. Obviously, I've told you in the class that nitrobenzene undergoes reduction so that you will get phenylamine. इसको हम इस तरह से भी लिख सकते हैं C6H5NO2. So in order to convert NO2 into NH2 into directly, I'm going to use 10 concentrated HCl mixture, which will serve as a reducing agent. And condition is going to be reflux. Okay. Identify an organic compound that can be converted to this by reduction reaction. Identify the reagent for this reaction. When aliphatic amines undergoes reduction, it will turn to amine. For that, if you remember in A1, CH3, CH2, 1, 2, 3, CH3, CH2, CN. And when you treat it with hydrogen in the presence of nickel catalyst, it undergoes reduction to give amine. So CH3, CH2 will remain as it is, और जो CN है वो convert हो जाएगा CH2, NH2 में, and that's the compound given in the question. So organic compound has to be this. That's propane nitrile. And the reagent used for this reaction is hydrogen gas. Okay. And condition is going to be nickel. right? The examiner is not looking for the condition, so we don't need to write nickel catalyst. By the way, you can form amine when amides undergoes reduction with lithium aluminum hydride. Okay, that's also a possible, answer in this part for this part. So propanamide undergoes reduction in the presence of lithium aluminum hydride, and as a result, you will get uh, aminopropane. That's an alternative answer, which is also acceptable in the paper. Obviously, if I'm going to use propanamide, then lithium aluminum hydride is going to work. Hydrogen gas won't be the reagent in that particular case, okay? And that's what we have done in the class also, if you remember. Um, Identify a single test that will distinguish between phenylamine and aminopropane by producing a white precipitate with only one of these amines. Draw the structure of the compound that is precipitated. By the way, phenylamine can react with aqueous bromine to give white precipitates, whereas this aliphatic amine cannot react with aqueous bromine. So testing reagent is going to be aqueous bromine. With phenylamine, give the positive test. The structure of the compound that is precipitated. Since NH2 is an orthopara directing group, it increases the electronic density on orthopara position, that is second, fourth, and sixth, which is why bromine is attached to second, fourth, and sixth carbon atom. That's called 2,4,6 tribromophenylamine. That's the product that gives you white precipitates. Okay. Next part of the question, describe the relative basicities of these compounds. So aliphatic amines are more basic than ammonia, and ammonia is more basic than aromatic amines. That's what we have done in ionic equilibria also, in organic chemistry also. The most basic is aminopropane. Least basic is phenylamine, and ammonia is in the center. So phenylamine में क्या होता है? It has 4 marks, so we need to give 3 points for the explanation. In phenylamine, lone pair of nitrogen is delocalized with a benzene ring. So lone pair is not available for protonation. In aminopropane, due to positive inductive effect of alkyl group, it increases the electronic density on nitrogen atom Lone pair is easily available for protonation. In ammonia, due to lone pair, can accept a proton easily. Okay, so that's the end of this question. Let's move on to the next part of the question. Oh, that's another question, guys. Propanoic acid, methanoic acid, and ethane dioic acid, or all weak acid. Draw the displayed formula of ethane dioic acid. By the way, we have done that in class. Ethane dioic acid is basically a carboxylic acid, and it is acting as a reducing agent also in redox reaction. Or displayed formula, so we need to mention all the bonds and all the atoms, right? So this is OH, this is OH, okay? The three acids, propanoic acid, methanoic acid, and ethane dioic acid, can be distinguished using combination of the two chemical tests. Neither testing reagent is an acid-base indicator. Identify two suitable testing reagents and complete table 10.1 to show the observation from each test. Reagent number 1. Propanoic acid, methanoic acid, and ethane dioic acid. So methanoic acid can react with Fehling solution and tolerance reagent. Okay. Tolerance reagent. Remember, tolerance reagent is a weak oxidizing agent. You can also use Fehling reagent. Okay. And reagent 2 is K1O4. Okay. In the presence of acidic medium. So propanoic acid cannot oxidize with K1O4, cannot react with tolerance reagent, which is why no reaction. Okay. Methanoic acid can react with tolerance reagent, and because of that, silver mirrors form. Okay. And reagent 2 is basically color is purple, it will turn to colorless. So technically, methanoic acid, KMNO4 oxidizes methanoic acid into carbon dioxide. That's what we have done in the class, right? Remember that. We need to balance equations. So we need to put 2 hydrogen ions and 2 electrons here. And for MnO4 negative, it has to be like this. So this reaction takes place. As a result, color changes from purple to colorless. So these two half equations were used when methanoic acid involves oxidation with KMNO4, okay? Ethane dioic acid cannot react with Fehling solution or tolerance reagent, so no change. In fact, no reaction, okay? But when ethane dioic acid undergoes reaction with KMNO4, color changes from purple to colorless because ethane dioic acid is basically reducing agent. When propanoic acid is treated with chlorine gas in the presence of ultraviolet light, a mixture of products is formed. That's called free radical substitution reaction. One of these products is 2,2-dichloropropanic acid. Explain why 2,2-dichloropropanic acid is stronger than propanic acid. 2,2-dichloropropanic acid. Chlorine has a stronger negative inductive effect and also it is attached closer to the functional group. Hence, ionization of hydrogen becomes easier. And also, chlorine stabilizes the anion. All right. That is the case actually. CH3, C, COOH. This is one chlorine atom. This is second chlorine atom. This chlorine has a negative inductive effect. This chlorine also has a negative inductive effect. This carbon atom becomes electron deficient. To eliminate its positive charge, it pulls the electrons from carbonyl carbon. As a result, this carbonyl carbon is extremely electron deficient. When this carbonyl carbon neutralizes its positive charge, it pulls the electron from oxygen. Being a more electronegative oxygen, has a positive charge is extremely unstable condition. To neutralize the positive charge of oxygen, it pulls the electrons from hydrogen, and as a result, hydrogen in the form of hydrogen ion takes place easily. So I can write one more statement here that these two chlorine atoms weakens the OH bond. Which is why ionization becomes easier. Two chlorine atoms weakens the OH bond also. Okay, that's the end of this question also. Let's see what we have in the paper. Oh, that's the end of this paper, guys.